Hello again. So here's the second part of question 27. We've done part A and we've got that. Now part B, hence solve this lot. Well, you can see from part A we've got the sine 2x cos 2x part, which is the sine 2x cos 2x part here. So we're just going to, we do have to deal with that little 2 in front. So I'll just write over here so you can see clearly what I'm doing. Just dividing both sides of this equation here by the 2 would give me that sine 4x over 2 equals sine 2x cos 2x, and that's what I'm going to use in this solving thing here. All I've done is divide both equations, side of both equations by 2. So let's write that. So now, therefore, we have the sine 4x over 2. Whilst I'm at it, I'm going to take, no, I'll do it all in one, I'll do it carefully, 1 root 3 over 4 equals 0. Okay, now subtract root 3 on 4 from both sides. And multiply both sides by 2. You see the 4 divides into the 2. 2 divides into 4. Right. Now we just have to solve this. We are in the calculator section of the exam paper, and I think that if you've done this lot, it's a 4-mark question. You have to show some working when it's 4 marks, even though you're in the calculator section. And I know you could have entered that and just solved it using the calculator, but you wouldn't have then done the hence solving business. So you have to use what you've done when it says hence. You have to use what you've already got to then go on and do that, and you're required to show some working for that to get the 4 marks. Now, if you've got to this stage, I think then you could pick up your calculator and just do the solve on that in the given domain, and that would be sufficient to get you full marks. I'm just going to keep going here doing the whole algebraic solution, but I think that it will be interpreted. I was there for the discussions this year that yes, if you've got this far, it was okay from there on to use the calculator to then get full marks. Anyway, here we go. Here's the whole algebraic solution. We need to find the basic angle, and that is the sine of what gives you root 3 on 2. Remembering we ignore the negative sign to find the basic angle, and you should get that comes to be pi on 3. Then we have to look in using the cast diagram to find which quadrant we're in. Now sines are negative there and there. We mark in our basic angle to the horizontal, so that's pi on 3 there and pi on 3 there. And now we have to look to the domain for our solutions. Now x is between 0 and pi, but you'll notice here we've got 4x for our particular equation, so we are going between 0 up to 4 pi for 4x. 4x is in there. So starting off at 0, our solutions are, we would end up with 4x equals 2. Now coming round in this direction, the first one we come to is there, which is pi plus pi on 3, which is 4 pi on 3. The next one comes round again, we get to 5 pi on 3. We're allowed to go round as far as 4 pi, so we've just done 2 pi, we'll keep going again, so we'll just add 2 pi to each of those. And 2 pi is 6 pi on 3, so we'll get to 10 pi on 3 and 11 pi on 3. Then we'll divide everything by 4 to find what x comes to, and it comes to, that'll just give me pi on 3. That'll give me 5 pi on 12. That'll give me 10 pi on 12 and 11 pi on 12. I can simplify one of them. X comes to pi on 3, 5 pi on 12 divided by, we get 5 pi on 6 and 11 pi on 12. And that, all being well, will be all the solutions. Probably a bit unnecessary to go through all that lengthy working in the calculator section, having got to the equation that sine 4x equals negative root 3 on 2. But there we go, there's the whole algebraic solution to that.